right, so last time we went over what a logarithm is and just how to write the format, how to evaluate them, where the base goes, where the exponent goes. Now we're going to do like the visual of it and go through the graphs and their characteristics. So first we're going to start out with, you can't log a negative value, and I should have printed this on here, so I apologize, or 0. You can't log any negative numbers or 0. All right, so you can't log a negative value or 0. Let me just show you an example of why not. So for example, if you had log base 2 and you tried to put a negative number there, like say you tried to log a negative number, log base 2 of -4. What that's asking is 2 to what power gives you -4? So just think about that for a second. 2 to what power would give you -4? There isn't one. It won't work. That's why you can't do it. It's not a thing. Like you can't, no exponent in the world is going to give you a negative result. And watch what happens if you do 0. Like say you do log base 2 of 0, like if you try to log a 0, what that's asking is 2 to what power equals 0? Nothing. There's nothing that is going to work, because what would 2 to the 0 power be? 1. Like there's nothing that will give you 0. So that's why it won't work. Just mathematically, there is no number that's going to make that true. So whenever it says find the domain, you are going to take what's inside the logarithm. You can ignore all the rest of it. You just want what's inside, in this case, x plus 2, and you're going to set it greater than 0. Not equal to, because you can't include the 0. I just showed you, you can't log a 0. And you can't log any negative numbers, so just set it bigger than 0 and solve it. What would you do? Yeah, subtract 2. And so we've got x has to be bigger than -2. So putting that in your interval notation, it would be -2 to infinity, and that would be your domain. So you've got to keep whatever's inside the logarithm bigger than 0. You get to ignore all the rest of the problem. It's just the stuff that's inside. So for this one, you would take this part, this x plus 3 over x, and say, all right, that's got to be bigger than 0. I basically threw this on here to review. We did this back in unit 4. These are your number lines. You're going to make a number line for your x plus 3, a number line for your x. Do y'all remember this with the positives and negatives? This goes well whenever I teach it, so just do that again. This is going to change where? Good, -3, and then just plain x would change where? 0, good. Do you remember how you can fill it in if everything's normal? Because in this case, everything is straightforward. Good, it'll be negative and then turn positive. Again, if you're ever not sure, you can pick a test number and see if it comes out negative or positive, but if nothing's backwards or nothing weird happened, it'll be negative and turn positive. So now we're going to slice up our number line into these 3 sections, drawing like the little balloon strings. What's the overall sign for the first section? Positive. Good. Negatives cancel, so that'd be positive, and then it's going to alternate. This will be negative, positive. Do we want the positive sections or do we want the negative section? Good. We can't log a negative. We want the positive section, so it would be -infinity to -3. Union, and then what? Yeah, 0 to infinity. So again, I basically threw that one on there for us to review our number. All right, and then here come the graphs. Do you remember the exponential ones, how they were a swoop? We're going to invert that. It's an inverse function. So instead of having a horizontal asymptote, these ones are going to have a vertical asymptote. Typically, it's at 0 unless the graph shifted left or right. So did this graph shift left or right? Yes, good. What direction did it go? It went right to. So you can go right to, dot that in. Vertical asymptote is x equals 2. Horizontal asymptote is none. You want to fill in the automatic stuff first, because you don't have to really think about it. It's just an automatic answer. It's the exact same as the horizontal ones, except this one's vertical. So if it shifted left or right, you put that in. Horizontal is going to be none. What was the other automatic thing that we did for the exponential ones? Do you remember? Domain was all reals. For the logarithmic, The range is going to be all reals because they're inverses. So that's like the automatic step. Now, I'm just going to show you, you don't have to write this part down if you don't want to, but I'm just going to show you a couple examples. You just need to be a little bit more careful about what kinds of numbers you plug in. Like you just have to put a little bit more thought into what you're going to plug in. And just let me give you an example. Just watch, okay? For example, if you have a square root, like say this was x minus 5, you would start by plugging in what? 5, because 5 minus 5, 0. What's another good number you could plug in? 6. 6 minus 5 would be 1. Square root of 1 is 1. But you would not want to do 7 next. Do you understand why? Like, why would you not do 7? You'd get square root of 2. Without a calculator, that's going to be some crazy decimal. What's the next, like, good number to plug in? Good, because 9 minus 5 is going to give you 4. Square root of 4, 2. For the sake of practicing this, could you figure out the next one? Like, what's the next good number to plug in? $14. 14 minus 5 is 9. You even got extra sleep this morning, guys. 14 minus 5 is 9. Square root of 9 is 3. Do you want to try and find the next one? $21. 21 minus 5, 16. Square root of 16 is 4. My point is you just need to put more thought about what you're plugging in. Here's what it'll look like if it's a logarithm. The first number you would want to put in is 1. We don't start at 0 for these. You'd want to put in 1. Log base 3 of 1. That is 3 to what power gives you 1? What would that be? 0. Log of 1, no matter what base it is going to give you 0. Now, the next number you plug in would not be 2. 2 is not going to be good. We could do 3, though. If you plug in 3, 3 to what power gives you 3? 1. Put the phone away. 4 would not be a good choice. 5 would not be a good choice. Think through what's the next good number to plug in. Good. If you plug in 9, 3 to what power gives you 9? 2. What would be the next good one? Good. And then you would get 3. So do you see how you just need to put a little bit more thought into what you're plugging in? You can't just plug in whatever you want. Okay, that's the only difference. So looking at this one, I can't plug in 2. Why not? It would give you what right here? 0. You can't log 0. So what are we going to start with? 3. Good. 3 minus 2 is 1. Any log of 1 is 0. Okay, plus 3 is 3. What do you want to try next? Four is not going to be good. Is 5 going to be good? If you plug in 5, 5 minus 2 is 3. Log base 4 of 3. 4 to what power gives you 3? Okay, so that's not a good choice. What do we want to try? I'm letting you struggle because this is how you learn. 6 would be the next good one. Okay, look. 6 minus 2 is 4. 4 to what power gives you 4? 1 plus 3. Do you hear how a lot of you went, oh, now I get it? When you struggle, that's how you learn. I understand you're going to hate me a little bit. I understand that the anger gets directed towards me because I'm the only one here. I'm a big girl and I can take it. I know that this is what will benefit you the most, all right? Let's try and think of one more. 10 minus 2, 8. 4 to what power is 8? Oh, wait, everyone. It's going to be kind of a big number. It's going to go off the graph, but that's okay. 18. Good. 18 minus 2 16. 4 to what power gives you 16? 2 plus 3, 5. Nice job, guys. That was awesome. I'm proud of you. All right, go ahead and plot them. You're going to get a sideways swoop. And yeah, 18.5 went off the grid. It would be like over here somewhere. But here's my pep talk. You struggle with that. What do I always tell you to do? If you can't get the graph, what do? Make it up. I would like for it to be a sideways swoop, like make the shape at least right. Invent something. I can take off the point for that. If all of this matches, you get credit for all of this. So it's not that big of a deal, okay, in the grand scheme of things. All right, domain. It's not going to be all reals. Domain would be from where to where? Good, 2 to infinity. X-intercept, let's come back to that. Y-intercept. None, good. I always save the hardest stuff for last. Do the easy stuff first. Are we increasing or decreasing? It'll be one or the other. We are increasing, hold on a second because this thing froze. We are increasing for the entire domain. So it would be 2 to infinity. Decreasing is none. Hey, but Ms. Cole, when we did the exponentials, it was all real. Yeah, because their domain was all reals. Okay, these ones aren't. Now the end behavior is a little different. You can't go to negative infinity. There's no graph over there. Okay, what's the farthest to the left you can go? Where is it fenced in? At 2. So it's going to be limit as x goes to 2. And then what you put in there is a little plus sign. That's to indicate that it's from the right-hand side. We're going to 2 from the right or from the positive side of the function. It is just new notation. I understand anything new is scary. I promise you'll get used to it. It'll be fine. We're going to 2 from the right. Where is that arrow pointing? Down, so negative infinity. And then limit as x goes to positive infinity. I know it's not super dramatic, but where is this arrow going? Yeah, it's going up. I know it's not like in a great big hurry, but it's headed upwards, so positive infinity. All right, let's go back and get the x-intercept. It should be something, comma, 0. So what you're going to do is take this equation. You've got plenty of space down here. Take the whole thing, set it equal to 0, and we're going to solve it. You're going to get stuck. No, I'm not Miss Cole. I'm a genius. No, you're going to get stuck. What's the question when you get stuck? What is the base? Remember Megan Trainor? What's the base? Okay. What do we do to both sides first? Yep, subtract 3. I'm stuck. All right. What's the base? 4. Good. To the power negative 3 equals x minus 2. So what is 4 to the negative 3? Good. 4 cubed is 64. We 1/64. We want to add over the 2. Now you don't want to write plus 2. That doesn't help you. You need for it to be 64ths. How many 64ths is 2? Good. How'd you get that? Because that's correct. 64 times 2. And so adding those together, you would have 129/64, comma 0. You're like, Miss Cole, that was hard. It's an advanced math class. You're going to be okay. We did 64 times 2. We got 128, and then we added 1. I really promise you're going to be okay. I get everybody through it every year. Okay. Let's do the automatic stuff first. The vertical asymptote, it's usually at 0 unless you shifted left or right. Did this graph move left or right? Left. How much? 1. Good. Go ahead and dot that in. Vertical asymptote is x equals -1. Horizontal asymptote is none. What's the other automatic thing I can put in here? Range will be all reals. Good. For exponential, domain was all reals. So for logarithmic, range is all reals. Now let's try and get some points. It's tempting to start with -1, and I totally get that, but you can't log 0. So instead of -1, what do you want to try? Oh, I do want to do 1, but what even before 1? 0. Good. Okay. If you plug in 0, 0 plus 1 is 1. Any log of 1 is 0. And you should be really happy that that turned out to 0, 0. How come? You want to be like, yes, because that's going to make your life easy over here. Why? It's going to be the x and the y-intercept. If you even want to just go ahead and fill that in, anytime you get the origin, you want to be like, hallelujah. That just makes life so much easier. All right, now let's do 1. 1 plus 1 is 2. 2 to what power gives you 2? 1. Good. What's the next number you want to plug in? Good. 3 plus 1 is 4. 2 to what power gives you 4? 2. Good. Go ahead and plot them. You will get a sideways swoop. Again, if that's a struggle, make something up, and then I can give you all the points for all the characteristics. Did you feel how that one went better than the first one? That's like called learning. It's like how that works. Everyone wants everything to be easy from day one, and it's like that's not how life works. And that's kind of actually the stuff I like to talk about with you guys because they're all right. Domain, from where to where? Good. -1 to infinity. Are we increasing or decreasing? Increasing. Just make sure you copy the domain. And again, for exponential, it's all reals because their domain is all reals. This one just isn't. So make sure that you copy over the correct answer. And then end behavior. Again, you can't go to -infinity because there's nothing over here. The farthest you can go is where? -1 with a little plus from the right. One of these, I can't remember which one. I have one that comes from the left. You just put a little negative. All that is. All right, where is that arrow going? -infinity, good, and then limit, bless you, as x goes to +infinity of the function. It's not dramatic, but it is going up, so +infinity. It's just the direction that it goes. All right, these last two. What is the base for these ones? E, which is about 2.718, blah, blah, blah. You're only going to be able to get 1 point instead of 3. Okay. Did this graph move left or right? Left 4. Go left 4. Dot it in. You get x equals -4. Horizontal asymptote is none. And then also the range is all reals. All right, so let's try and get a point. What can we plug in? If we plug in 1, we'll get ln of 5. I can't do that without a calculator. It's going to be negative something. -4 is close. The only reason I can't do -4 is because that gives you 0 and you can't log a 0. Good. Perfect. Nice job, guys. All right, -3. That'll give you 1. Any log of 1 is 0. -0 is still just 0. -2 is -2. So that's the only point you can plot, -3, -2. And then again, just like we did with the exponential ones, here's where everyone stares at me like, Miss Cole, that's 1 point and an invisible line. What on earth are we supposed to do with that? The graph either increases or decreases. You have a 50-50 shot. Do you see a negative anywhere in that equation? Yes, it's been reflected. It's upside down. It's going to decrease. Do you see how this one goes like this? We just flipped that over. Like this one, that basic shape, we just flipped it over. But again, you got a 50-50 shot of guessing. Give it your best guess. All right, domain would be -4 to infinity. We're going to do the intercepts last for this one. Those are going to be, we're going to have to work a little for those. Right? We are decreasing, so increasing is none, decreasing, just copy over the domain. And then the last thing is the end behavior. It will be limit as x goes to -4 from the right of the function. Oh, and now where is that arrow going? Infinity. We flipped it over. And then the right side, limit as x goes to positive infinity of the function. That one's going down, so negative infinity. All right, now we got to go back and get the intercepts. All right, I'm going to do the y-intercept first because it's a little easier. You would just plug in 0 and whatever you get, you leave it alone. Okay, you ready? 0 plus 4 is 4. It will be negative ln of 4 minus 2. Whatever that is, let me grab a calculator and I'll show you. Negative ln of 4, what was it, minus 2? What are you expecting it to be about? Like, where does this y-intercept look like it is? Like -6-ish, -7. I mean, our graph's not perfect, but like close enough. Oh, well, I didn't bend mine exactly right, but negative-ish. Do you know what I'm saying? That's what that came out to. You just leave it alone. All right, the x-intercept is going to be something 0. We're going to set the equation equal to 0. Just use this space that you've got over here, and we're going to solve it. So what would you do to both sides? Add 2. And then you would divide by a negative, so it's going to make it a -2. And then you would be like, I'm stuck, which is fine. What's the base? E, good. It's e to the -2 equals x plus 4, and we're almost there. Last step. Subtract 4. So it's e to the -2 minus 4. Whatever that is. Here, let me show you. E to the -2 minus 4, -3 and a little bit. Does that make sense based on our graph that it would be around -3? Yeah. All right, but you just leave them like that. All right, one more. Did this graph move left or right? No, there's a reflection in there, but there's not a shift. Do you see that? Still going to be at 0. We didn't move left or right, which I know makes it hard to see, but that's on the axis. So vertical is x equals 0, horizontal is none, range is everything. Just go ahead and fill that in. And then we're only going to be able to get 1 point. Think about what you want to plug in. There's only one number that's going to work without a calculator. We can't log 0. If your brain starts there, that's fine, because then you're close. Just like kind of move it over. We don't want 0. We want what? Not 1, but good. We'd want -1 because then the negatives would cancel and it would be 1. Any log of 1 is 0. Perfect. Plus 1 is 1. So -1, 1 is your only point. Oh, look, it's over here. I told you I did 1 where it was reflected and from the left. Do you see that negative in there with the x? Okay, we did a reflection over the y-axis, so it's going to look something like this. All right, so domain, from where to where? Good, -infinity to 0. We'll come back to the x-intercept. I just always like to save the hardest stuff for last. It's not hard, but like more work. Y-intercept? None. There's an asymptote there. Are we increasing or decreasing? Good. Increasing is none. Decreasing, just copy over the domain. All right, so the end behavior for this one. We can go to -infinity now. limit as x goes to negative infinity. That arrow is pointing up, so positive infinity. Where we can't go is to the right. There's no graph there. So the farthest we can go is what? Limit as x goes to 0, and then put a little negative in there. It just is indicating from the left or from the negative side. And that arrow is pointing down, so negative infinity. We're just going to go back and get the x-intercept. You're going to take this whole equation, just use the space you've got over here, take the whole thing, set it equal to 0. And so we're going to subtract 1. And then we're going to be stuck. What's the question? What is the base? E. It will be e to the what power? Good. -1 equals the only other thing that's there, which is the negative x. And then you would just divide by a negative. So it's negative e to the -1, comma 0.